Now let's look at some sample problems. Number 1, a car rolls down an inclined plane. Assume that friction is negligible. Draw an FBD for the cart. And I've given you an example. In which directions do the normal force and the force of gravity act on the cart? First, draw the FBD of the cart. Now, the force of gravity on the cart is down, since Earth attracts all masses towards the surface at the center. The normal force is perpendicular to the surface. Since the surface of the ramp is tilted, the normal force is not directly up. This example clearly shows that the normal force and the force of gravity do not always act in opposite directions. Problem number 2, person accelerating in an elevator. A 50-kilogram person is standing on a bathroom scale inside an elevator. The scale is calibrated in newtons. What is the reading on the scale when the elevator is accelerating up, that's important, at 2.2 meters per second squared? So up is positive direction and down is negative. So determine the force of gravity acting on the person. So the force of gravity is mass times the rate of gravity, which is 50 kilograms. Now, because we're going up, it's negative 9.8 newtons per kilogram, which is negative 490 newtons up, which is really 490 newtons down. Step 2, draw the FBD of the person. I've given that to you. Determine the normal force acting on the person. Since the elevator is accelerating up, the person is also accelerating up. The person's acceleration is equal to the elevator's acceleration. So force N plus force G is MA. Fn plus negative 490 Newton equals MA. So Fn minus 490 newtons is 50 kilograms times 2.2 meters per second squared. So it is 600 newtons. The reading on the scale is equal to the normal force, 600 newtons. Problem number 3, pushing a person standing on a bathroom scale, something we'd all do. A 60 kilogram person is standing on a bathroom scale calibrated in newtons. A friend pushes down on the person with a force of 72 newtons. What is the reading on the scale? Up positive, down negative, except if we're talking about the force of gravity. So force of gravity is mg, so 60 times negative 9.8 newtons per kilogram, which is negative 588 newtons, which is 588 newtons down. Now you're going to draw the FBD. Determine the normal force. Since the person is at rest and not accelerating, the net force must be 0. Okay, substitute in your values and you get 600 newtons.